Amin.
Yeah, because we still don't know when this COVID pandemic will be over. We still don't know how it will end, or maybe we have to wear our mask in an unknown time. Speaking of which, people that we have, maybe this is our first international webinar. Yeah, we know that April is the Earth month. It is in. I'm a little bit forget if it's not in 21st or 22nd of April. We celebrating Earth Day. So yeah, in fact this webinar actually is the gate to celebrate Earth Day, and all of our speakers today is excel in their field of expertise, especially in environment. So we have Professor Tom here from Konken University and Associate Professor Siti Masana from Universitas Ahmad, Dahlan, and we have Professor Effendi. I think he's not in this room. Yeah.
I'm here.
Greetings, Professor.
Yeah, I'm here.
Yeah, thank you. I thought that you haven't joined this room.
Yeah.
Okay, so allow me, speakers, to open this event. So, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi
wabarakatuh.
Yeah, good morning. Greetings to all the participants today. So, as I mentioned before, we have our first international webinar on environment. So, we have 3 guests today. We have Professor Effendi as our first speaker. He is from UTM. And then our second one is Professor Tunyaluk or Professor Tom from Konken University. And last but not least, we have Professor, or should I say Associate Professor. She hasn't become a professor yet, but soon, from our beloved campus, Associate Professor Siti Masana. And today we will have our great moderator. She's also our beloved lecturer, Miss Hayati Mukti Asih, PhD. So without further ado, Professor Hayati, would you mind to take over the meeting and start this webinar? Thank you.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
warahmatullahi wabarakatuh.
Good morning, ladies and gentlemen. The Excellency, the Secretariat of Industrial Engineering Department is Hapsora Agung Jatmito, STMSC, and then the respectable all the keynote speakers and the honorable all participants of this international webinar. I'm Hayati Mukti Asih, the moderator of today's webinar. I'm very pleased to see you here and welcome all of you to this event. Please take applause. Yeah. The international webinar is held by Department of Industrial Engineering, Ahmad Dahlan University, Indonesia, and Student Association of Industrial Engineering, Ahmad Dahlan University, Indonesia. This seminar will discuss about the current research and development of environmental sustainability. This is an interesting topic to make the consumption and production more responsible in order to minimize the environmental impact. This phenomena will be discussed clearly by all the keynote speakers. Today, we have 3 honorable speakers for 3 different countries. They are Professor Tunyaluk Rakudi from Konken University, Thailand. Good morning, Prof.
Good morning.
Okay. Associate Professor Dr. Effendi Muhammad from University Tehnika, Malaysia. Good morning, Prof.
Assalamualaikum. Morning.
Waalaikumsalam. How are you?
Fine, thank you.
Okay. And Associate Professor Dr. Siti Mahsana Budijati from Ahmad Dahlan University. Hi. Doctor. Okay, ladies and gentlemen, the first speaker today is Professor Tunyaluk Ratpudi. He is a lecturer of in the Environmental Engineering Department at Khon Kaen University, Thailand. He has received his bachelor degree in Environmental Engineering at King Mongkut's University of Technology, Thonburi, Thailand, and taken his master degree at Chulalongkorn University, Thailand, in Environmental Engineering. His research interest is about water treatment plant operation. Now, allow me to welcome the speaker, His Excellency Professor Tunyaluk Ratpudi, to deliver this presentation. Please join me in welcoming Professor Tunyaluk Ratpudi with round of applause. Professor Tunyaluk Ratpudi, the floor is yours.
Oh, thank you very much.
Okay.
I thought I'm the second one, but it's okay to be the first speaker, and I'm glad to be here for the virtual conference. Actually, this is my first time joining the virtual conference. So let me begin with my presentation. I believe I have to share my screen, right?
Yep. Can you share your screen, Professor?
Yes.
Yeah.
Okay. You see my screen?
Yep.
Yes, yes.
Okay. All right, then. So it's okay. First of all, my name is Tunyaluk Ratpudi. You can call me Tom. I'm a assistant professor in the Department of Environmental Engineering, Khon Kaen University, and I'm now serving as a department chair now, and it's glad to be here. And I got invited from university in Indonesia, which is my first time. I'm very excited. The topic that I would like to share with you today is the biofiltration for treatment of recent emerging contaminants in water and current and future perspective. You might have heard about biofiltration, or you may not, but actually it has been with the water industry for, I think, more than 20 years, but we're gonna see the development of the current use of it now. Actually, the picture here that you can see is the pilot scale of biofiltration columns, and actually we use it in the water treatment, but this is like a setup for the pilot scale here. Let's begin with the outline of presentation today. I'm gonna talk about I'm gonna have to use the pointer here. All right. Okay. I'm gonna talk about the current stage knowledge of biological enhanced activated carbon filter, and what is the application that we have used in the water treatment, and next is the mechanism of biofilm formation and contaminant treatment. And then I'm going to talk about the operational parameters that influence the process, the BAC process, and then the performance or the recent emerging contaminant for treatment of that contaminant that we concern now. Okay, and also we're going to talk about the new media that have potential to develop for the treatment. Okay, you can see from this picture that a lot of time when we use the filtration in the water treatment process, on your left hand side, this is typical filtration process, which has coal or anthracite at the top, and then we have a sand filter. There's a sand media here, and then we have a gravel to support the sand. But what actually do for the filter are the coal, anthracite, or we call anthracite, we can call coal, and then sand. So the particle will be trapped in the void of the sand or the coal, and then the gravel is to support, and then the water is flow from the top to the bottom, and then to the clay block that collects the water. And this is very typical water treatment process that we have, like conventional, like for the big city. We're gonna have this is to filter the water to make the water much more clearer, and then and also help remove some of the pathogens too. Okay, this is one of the process. Okay, and then we do the disinfection and everything using adding chlorine. Okay, but on your right hand side is the biological activated carbon filtration. So basically, what is the difference that we change the media? We change the filter media to be the activated carbon. Okay, the media can trap the particles too, but what we want from the media is not only trap the particle, but we want to grow the bacteria or microorganisms in the filter, and this will help in degrading the contaminant, because the bacteria or microorganism can use it as a food to to eat, and then make the water cleaner. Okay, but the thing is, the difference from these two is we also have some biological activity going on in the sand filter too, but in activated carbon we can have more, and the reason why we can have more biodegradable activity, biological activity going on, because in the structure of activated carbon there's so much of surface area. We're talking about the surface area of about 1,000 square meter per gram. So there's a lot of pore inside internal structure of pore that can absorb the contaminant, and then can have a space for the microorganism to grow. So this is the advantage of using activated carbon as a filter media. During the talk, you may stop and ask a question so far as, or you can wait for the end. That's fine. Please let me know. And this is the typical application of biofiltration that we have. For the first picture, we have a rapid sand filter, which is the sand filter here. And the water is from coagulation. We add alum to coagulate, make the turbidity colloidal particle come together. We have a sedimentation to settle down all the heavy particles, but still we're gonna have the kind of light particle that will not settle, and then we filter it out with sand. Okay, but a lot of time the sand filter is not enough, so they're gonna add the BAC, the biological activated carbon filter, after. So the water is much better in terms of removing the organic compound or other organic contaminants. The next application is the ozone and BAC filter. We have the water from coagulation and sedimentation process. And then we add ozone in here. Ozone is for disinfection, and it also break down some of the organic contaminants, organic compounds, or compound like a taste and odor compound. Okay, so when it break down the compounds, it's like you chop it into small pieces, and it become easy for bacteria or microorganisms to remove it in the water and the effluent. So the water become less organic contaminant. Okay, and what happens is when it have less organic contaminant, it have more stability in the water treatment system, because when we send out the water, and if we have a lot of organic contaminant, the microorganism in the pipe can use the organic compound as a food source to grow. Although we add chlorine in the pipeline, but sometimes some location, the chlorine residue is not enough. So the microorganism can grow again. Another advantage is that if we have lower the amount of organic carbon in the water, and when we add chlorine, we're gonna have less formation of the disinfection byproducts, for example, THM, which is carcinogen. So the more we reduce the organic compound, the less we have the carcinogen in the tap water. So this is a practice that we have been using in the water industry for 20 years. Okay. Also, another application that sometimes people use the other process like UV hydrogen peroxide, which is the disinfection and oxidation too, to remove the organic compound. This is the same thing that ozone does, that break down the organic compound. So the water comes from the coagulation past a sand filter to remove the particle, but still have some organic contaminant. And this UV hydrogen peroxide is the advanced oxidation process. It generates the hydroxyl radicals to break down the organic compounds. And then this organic compound goes to the biological filter, the BAC. And then this BAC, the microbe in a BAC use it as a food source. So the water is much better, much cleaner. And the last one, this is for the potable water reuse. What potable water reuse is basically mean that we use the wastewater to produce the drinking water. The wastewater from here have to be treated very well without remove as much as contaminant as we can, the organic contaminant, the pathogen, the nutrients, and then we add ozone. Ozone is do the same thing, is break down the organic compound, and then it's come to biological activated carbon to remove the compound that broke down from the ozone. And then the water pass through membrane filtration or directly go to UV for disinfection. And we can use it in for drinking. So you might see, okay, this is not acceptable, but it's happened in the real life, like in the area that have a limitation or have a water shortage. For example, in USA, in California, they have the potable water reuse plant. So their wastewater treatment did a really good job in treating wastewater before putting back into the river. But they have an idea that when they have the water shortage, that the water that they put in the river is much better than the quality in the river. So, and they have a water shortage. That's why they just directly reuse it, make it potable. So this technology has become domestic for the in some area. Like, yeah, again, this is not new. This is like space technology that people that, you know, when they make the spaceship, people go into the space. They have this kind of technology to recycle the water. So that's the same thing, and they have been using it for many years. Okay, so these are the example of the BAC application, and how this work. I mean, how the biological treatment works and how does it happen. When we look inside the structure of the biological activated carbon, we're gonna have the what's called biofilm formation. So this biofilm is from like small and many microorganisms. So they start to attach on the surface here, and they start to grow, and they start to grow more, and they form the colony, and then from the colony they kind of release the substance, you know, to make them attached to the surface. And after some time, they start when it gets mature that too much of population, or there's some shear force of water, so they start detaching, and then start attaching again, like this. The water flow here, and they attach, and then they form the biofilm, and then they start spreading again. So this is the how biofilm form in the biological activated carbon filter. And a lot of time we're gonna have the biological activity going on at the top layer, on the top layer here. Okay, the bottom we also have it, but there's a lot in the top portion of this one. And the microorganisms use the organic compound in metabolism process. So use it as a carbon source or nitrogen source, for example. Another mechanism that going on here is we call the adsorption. Since the activated carbon has a pore size, a lot of pores in there, so the contaminant get attached on the surface in the pore. And when that happens, we remove the contaminant already. And then the microorganism sometimes helps degrading this contaminant too. This contaminant. Okay. And when we look at the activity in terms of total organic carbon removal, like in the water, we measure the amount of organic carbon in as a the parameter is called total organic carbon, or TOC. You can see the red line here, the red line here. This is the performance. Like 100% is like one is 100% removal, but actually we are not. We not be able to remove all of that. But at first we can remove like 80–85%, and the red line here is kind of going down like this. This is because of the activated carbon. It serves as an adsorption. The mechanism for serve as an adsorption. Okay, but you can see after several months, this is kind of going down because all the adsorption capacity has been used up. Okay, but it's not like used up by 100%. We still have the capacity for removal of TOC. This is because we have a biological activity going on here, so it can remove the organic contaminant. So this is how it works. You're gonna see the first period it can remove very good. This is because of adsorption. Once the capacity of adsorption is exhausted, so there's only biological activities going on. Okay, but it takes several months. So why is its benefit here? Because it's benefit because if we use the activated carbon only for adsorption, we may have to replace it like every 6 months or 8 months. But if we intend to use it for biological activated carbon filter, we can use it for 2 years, 3 years, or 4 years before we replace the media. Now, what is the effect of condition that affect the performance? The first thing is pH of water. Lower or higher than neutral, than 7, we're gonna have less integrity of microbial cells, and we have less biofilm formation, and we have less microbial activity for contaminant transformation. So higher or lower than 7 is not good. We try to keep it around neutral. That's the better. It can be off a little bit, but it shouldn't be that much off. Another one that we concern is the contaminant. For some substance that we put in the water, it will promote the biofilm formation. But a lot of time we have the toxic contaminant that comes in the water. So it reduces the biological species, the microbial community. Like first we have like maybe 100 types of bacteria in there, but when we have a toxic compound, it's kill the most of it. So we just have few microorganisms, which is not good. Like you have to have a diversity of microbial population in the filter, and sometimes it can form the persistent byproduct in treated water, which we don't want that. So this is very important when we use the biofilter, that we have to make sure that we will not create more toxic compound in the water. Another effect is the temperature. We want to have the optimum temperature, which is mean not too hot or not too cold. So we're gonna have a good enzymatic activity and diversity and biofilm formation. I experienced myself when I was working in the water treatment plant in the US, and what happened is during the winter time, the temperature is dropped to almost 0 degrees Celsius. And when it does happen, we lose the biological activity of the water because the water is too cold. So it won't active. It will not. It doesn't act. It did not active at all. So we lose that when the temperatures go down. But actually, there's nothing we can do with the temperature. But in the area or the country with doesn't have much the swing of the temperature, like Thailand, Indonesia, I don't think this will be an issue. But in a country that having the cold weather, it's gonna be the issue that low temperature could affect the performance. Also, but hot temperature, like high temperature, could affect the performance too. It can kill the bacteria too. But this one might have to do with like if we use it in the industry and then we have a hot water from the boiler or something that come into the process, we're gonna have that problem. The last one is the media. Sometimes we have hydrophobic media, the surface, which is good because we have more microbial attached and biofilm formation. And the media that have a macropore, sorry for my PowerPoint font here, we have increased number of enzyme and biomass content. So we have like more space for microorganisms. And sometimes we have media size which larger size. This is one issue too, because if media is packed up too much, we're gonna have the head loss build up quickly. So that's another issue. So media size have to be appropriate. So the larger the media, the less of the head loss build up. But also maybe the larger media, but it cannot trap the particle really good. So we have to kind of balance it. So now let's move to the contaminant. In the past, we talk about the contaminant which is conventional. For example, turbidity, natural organic matter, taste and odor, heavy metal, and nutrients. And then lately, we have we call emerging contaminant, which is kind of new class of contaminant that had more effect to the people, and concentration is very low, like nanogram per liter or part per billion level. Like these are the compound like pharmaceutical, hormone, pesticides, hydrocarbons, MTBE. MTBE is the compound that add into gasoline to prevent the engine from knocking. So it's an anti-knocking agent. And I believe that this compound has been banned in the US, but I'm not sure about the other country. This is one of the bad contaminant, the bad compound that they have been invented. So it has been contaminated with the groundwater in many places in the world. And then we have a trihalomethane, which is the disinfection byproduct, which is carcinogen. And we have haloacetonide, haloacetic acid, which also have with also carcinogenic disinfection byproduct. These two are the compound that conventional. Typically, we add chlorine, it react with the organic compound in the water and form. But still, this is not quite new. This has been known for some time. But recently, we have a new contaminant, more contaminant coming every day. This is called nitrogen disinfection byproduct and iodine disinfection byproduct. These are more toxic than THM and HAA. So this is like this. The compound is smaller. Is lower in concentration, but it's more toxic. And we have nanomaterial. We use a lot of nanomaterial today, like a silver nano or titanium dioxide or zinc nano oxide particle. And we have microplastic, which is the problem now in all of the world. I would say that we have a microplastic in the raw water, and then we probably have microplastic in the tap water. And then the last one is the PFAS or fluoroalkyl sulfonate. So this is another bad boy here that we recently found that this is a problem. I'm gonna talk about it more later on the slide. These are the example of the compound of disinfection byproduct. And we have DBP class, and the white one here, THM and HAA, these are the disinfection byproduct, but not really recent, not really recently emerging. But the yellow one here is very new compound. It's very new compound. Most of the compound is nitrogen and iodine based compound. Here, that some of the compound, can be removed by BAC, but some compound it cannot be removed by BAC. So what does it mean is that our technology today may not be able to treat some of the disinfection byproduct, but our technology can treat some of the disinfection byproduct. So we have to kind of be careful, in terms of monitoring this compound that cannot be treated by BAC, and then find another way to deal with the problem. These are the effect of ozonation, and like I said, ozone actually break down the contaminant. And if we don't have the biological filtration, the number 15, 30, or 60 is the time that water spent in the biological activated carbon filter. The more time it's spent, the more removal. So if we don't have the biofilter, it could not be removed this compound. This is all the disinfection byproduct here. Okay. So the more we add ozone, the more we get rid of this compound at the first, so like from about 3,000, so we get down to about like almost 4,000. We get down to about 3,000. The more we add ozone, the more we remove the compound, so which is good. Another one that factor that affect the BAC is the number of bed volume treated. So when this is called NDMA. NDMA is another disinfection byproduct compound, which is carcinogenic too. This water has been treated with ozone and passed through biofilter. It has been tested for like almost 400 days, and the bed volume is up to about 70,000. But the first period here, when the biological activity is kind of exhausted, so the capacity is gone. So we see the decreasing of the performance. What happened in this tell us that if we, keep monitoring, and sometimes we didn't wait long enough, we might see, okay, here we kind of give up at this point. Then, okay, we have to change the filter media, replace it, and spend money. But if we wait for some time, the biological activity is taking place, it's taking control. So it's kind of come back here. Absorption capacity is not running out yet. Another concern is sometimes we have release of soluble microbial byproduct. And this is the picture of the fluorescent image that show, okay, before this is new filter and this is old filter. We have increase of the compound that fluorescence. What happened is it will contribute as a nitrogen disinfection byproduct precursor. So that another thing that we have to be careful when applying the biological activated carbon filter. So what we can do is we have to keep cleaning it by backwashing it so that it will not be much of releasing of the soluble microbial byproducts. Another compound, nanoparticle. We have zinc oxide nanoparticle, cerium oxide nanoparticle. So sometimes it coated with the PVA is kind of glue. We have titanium dioxide, silver nano, silver citrate. This compound is very stable in BLC filter. It could be removed by the biofilm, but it has the effect on the biological activity in the filter. It could inhibit the AOB, which is ammonia oxidizing bacteria, and lower the number and biodiversity of the bacteria. So this is one thing that affect the biological activity in the filter. And this day we're gonna see a lot more of the nanoparticles. Like for example, we use the nanoparticle in the detergent to clean the clothes or in the washing machine, or we use it as a cosmetic products. So we're gonna see a lot more of this problem. And then microplastic and plasticizer. These are the compound of microplastic, and it doesn't remove by biological activity, but it mainly removed by absorption. What that means is eventually if we have microplastic coming through, the biological filter cannot retain it. It will pass through. Finally, this is the last bad boy here. It's called polyperoalkyl substance, or PFAS. This compound contains fluorine and then carbon. It can be used in a lot of industry, but one of the common thing that we know is in non-stick pan or Teflon, and then maybe food packaging, so it prevents like sticking. So what is happened is it can affect a lot of health in terms of nerve system. So it has been known for some time as a contaminant of concern. The concentration in the water is very small, but it can have a lot of effect. So the biofilter was found that was not effective for PFAS removal. The mainly removal mechanism is by absorption. Sorry, by absorption. And the activated carbon, it worked for long chain, for carbon more than 6, but not for smaller chain. It's carbon for less than 6, so it doesn't work here. So it's something that we have to look into what we should do next with this compound. It's very challenging. But if you want to know more about this compound, there's a movie called Dark Waters, is in 2019. So this is a movie the story is based on 2 stories in the US. You might wanna, if you are interested, you might wanna follow. Maybe like I'm not sure if Netflix has this movie yet, but this is very interesting movie, and the actor here is the guy that plays if you know Marvel, like Hulk, and that's the same actor. So yeah, I haven't seen this movie yet, but I think it's a good one for environmental application, and DuPont is responsible for the PFAS contamination. Okay, and for the last one slide here is a new media, that biochar. Why are we talking about biochar? Biochar is the material that used in the agriculture to hold soil moisture. So it has been used, but it's very new for water treatment industry. And why we interested in a biochar? Because it had less cost compared to GSC, and it can be modified to be a new media, new material. So we kind of looking forward for development of biochar. Biochar basically is the biomass that we burn it as a char, but it's less processed compared to activated carbon. So we kind of looking forward to development of the biochar as a new media, or modified biochar. So the biochar also have the pore size too, so it can absorb decontaminant. Finally, if you are interested in the topic that I talk, we have the just we recently published the paper here. So I already sent the file to the conference organizer that you may ask from them, or you might be able to download it online. I put the link on DOI here. So with that, I would like to thank you all for attention, and I'm here to open for the questions.
Okay, thank you very much, Professor Tunyaluk Ratugdi, for giving such informative and interesting presentations. Before we go to the next speaker, please leave the questions in the chat box, and then the speakers will answer it on the fourth sessions. Now, we go to the second speaker. He is Associate Professor Dr. Effendi Muhammad. He is a lecturer of Manufacturing Management Department at University Technical Malaysia Melaka. He received his bachelor's degree in manufacturing engineering from University of Malaya, Kuala Lumpur, and master's degree in engineering business management from Coventry University, United Kingdom. He completed his doctoral course in Intelligent Structures and Mechanic System Engineers in University of Tokushima, Japan. His interests are in a lean manufacturing system and operation management. Now, allow me to welcome his Honorable Associate Professor Dr. Effendi Muhammad to deliver his presentation. Please join me in welcoming Associate Professor Dr. Effendi Muhammad with a round of applause.
Hello, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Waalaikumsalam
Indonesia is still
warahmatullahi
morning, so very
wabarakatuh.
good morning. I don't know, Indonesia almost 12 o'clock, right?
No, it's still 10 a.m.
Oh,
from-
10 a.m. Malaysia is
Yes.
already almost 11 o'clock. So both is still in morning.
Yeah.
So Alhamdulillah, terima kasih and for UAD for inviting me for this international webinar. Because we already have a collaboration together for almost 2 to 3 years. And because of this pandemic, I don't have the opportunity to go there. But Alhamdulillah, I managed to went there by Maya, by online.
Yeah.
Okay, so when I received invitation from Ibu Hayati talking about this talk, so I thinking about what type of topics that I want to give lah. Macam mana saya nak what is the best topic that I can provide that suitable for this event. So after discussion with some of my students, one of the topics that we have researched that currently that we have done is talking about the cleaner production, talking about the cleaner production, and also we combine it with the lean manufacturing philosophy for this issue of sustainability. So I think this topic is quite relevant with this webinar because we're talking about the sustainability and talking about the environment issue. Okay, yes. So maybe I will share my screen first. Sekejap,
Okay. Take your time, Prof. Okay.
So which part that, do you have full screen here?
Yep, already, Prof.
All right. So Assalamualaikum again and very good morning. So my name is Effendi. Right, I'm from UTM Kuala Lumpur. UTM Melaka, Malaysia. Sorry. So maybe this is just introduction first. Just one page. Where is Melaka? I think Ibu Hayati is very familiar with Melaka. And then, so Melaka, we call Melaka is a historical city, right? Historical city. And then they have a tagline where wherever that you already came to Melaka means that you already came to Malaysia, because everything in terms of historical or something like that, see, all majority is in Malacca, right? And Malacca also have already have UNESCO heritage, one of UNESCO heritage site, right? In the world. It's just almost only two hours from Kuala Lumpur or from the airport in Kuala Lumpur or in Sepang. So this is our main campus. All right. All right. So straight away go to the topic. So my topics today is I will discuss about development of cleaner production through extended value stream mapping to support the sustainable lean manufacturing. So when we're talking about the extended value stream mapping, so value stream mapping is one of the tool of lean manufacturing. That's the keyword lah. Okay, so Malaysia economic development through constant of transformation of its industrial base into high value added product driven by innovation, automation, and apply productivity to strive in increasingly competitive and open global market. Before this, so we know that manufacturing sector lead to the Malaysian economic value at least 22.7%. This is data in 2016, right? Of course, now currently the issue is different because of the pandemic. But when we get this data is on early of 2016. And then the manufacturing sector drowned out by 5% the year of the year in moderating global economic circumstances by 22.7% of 303 billion total of GDP of current prices. And then SME form the pillar of country economic progression because in Malaysia, almost 90% business or companies came from the SME. So actually in 2014, the Malaysia SME growth of 13.6% continued to outpace of the growth of overall economy with 35.9% of GDP share growing affected by strong domestic demand, right? So we can say that they can easily comply according with the environment regulation as compared to the larger industry, right? So this is talking about more on the manufacturing sector. And then for 2019, our late Prime Minister, he went to Copenhagen at the time. He said that I would also like to announce here in Copenhagen that Malaysia is adopting an indicator of voluntary reduction up to 40% in terms of emission intensity of GDP by year of 2020 compared to 2005 level in 2009. But in 2014, he said in a United Nations Climate Change Summit in 2014 that Malaysia already reduced the emission intensity of GDP by more than 33% by allocating finite national resources on adaptation and mitigation, nearly 2.6 billion in the last decade of mitigating floods. Right. So this is the main story lah. So sustainable waste management aim to recover, recycle. We know that sustainable waste management is aim to recover, recycle, reuse, reduce waste from industrial production. United Nations Conference on Sustainable Development, I think in 2012, known as a Rio 20, one of the most significant current discussion in the legal and moral philosophy is that a fundamental change in the way of society consume and produce are indispensable for achieving the global sustainable development. So at the time they say that the responsive for necessity to participate in sustainable practice among business is a means to widen their focus from the solely on economic well-being to the environmental and social dimension into the objective. Like if this is a figure that we have done, when we're talking about the sustainability, we're talking about talking about the environment, economy, and social, whereby For social environmental, we're talking about environmental justice, natural resources, locally and globally. And for environmental and economy, we're talking about the energy efficiency, subsidized incentive for use natural resources, and so on. And also for social and economy, or economy and social, we're talking about business ethic, fair trade, and workers' right. So it requires innovation in terms of production line to overcome all these problems, right? Because we know that an awareness to put the sustainable is very essential for their consideration from an economic aspect to the social and environment. So throughout the years of industrialization of environment has become severely polluted and contaminated, right? So legal requirements are enforced, to take care proper waste management in all the industry. So for example, we're talking about create local and global issue at greenhouse effect and Kyoto Protocol, industrial emitted pollution to the environment, rapid industrialization cause huge consumption of resource rapid and extensively, right? And this came to an idea by using the cleaner production and also lean manufacturing. We know that cleaner production, cleaner production is a method to minimize waste and pollution to the environment. And lean manufacturing is a method to improve production process by eliminating the waste. A number of studies actually have found that CP, or cleaner production, is a method to minimize and pollution load to the environment. For example, Frigin in 1999 or Hilson also claimed that CP, or cleaner production, aims to improve environmental production by adopting approach and seeking to reduce environmental waste and waste generation. And clearly we know that, for example, in 2002, Bushell said that lean manufacturing seeks to make the most efficient production process by eliminating waste in every stage of production chain. We know that lean manufacturing actually is one of the philosophy that have been taken by total production system, right? All the theory or the fundamental story came from the TPS. But at the time, James Womack, who are from US, because at the time in early 90s, the US people have problems, and then they learn the manufacturing from the Japanese company Toyota, and then they create the idea of lean manufacturing. But the basic fundamental understanding is the TPS, Toyota Production System. So when using lean principle to achieve environmental objective, it will bring us considerable cost benefit beside the CP implementation. So reason evident, for example, Prasad in 2014 said that has emerged, finding that challenge was emerging when the industry trying to combine environmental, health and safety concern with green product design, lean and green operation, and also closed loop supply chain. Right, people start to think about not only waste in terms of production, but also how to combine with the environmental, health, and so on. We also know that in 2013, Tiwari said, outlined that development of environmental operation management and integration of environmental and also the operation management in terms of great practice can give something to the product, not only for the company, but also for the economy, environment, and health and safety also. So, guideline for assessing lean manufacturing impact on working condition on employees, either a plant or department level, which have tested at assembly line. For example, in 2009, I think, Sorin have been tested this one in Brazil. So the impact of detected in that line may provide insight of other company concerned with balancing lean and also a good working condition. So since the method adopted for assessing the impact is fairly simple. It is workable alternative for company interested in surveying how lean manufacturing is affecting their operation. So the main purpose of lean manufacturing is to reduce and find. We know that the main purpose is of lean. Before this, I told you already, is to reduce and finally eliminate waste in the operation, such as waiting time, defect of material, waste, or so on. So in order to implement cleaner production with LM tool to detect where the hot spot of waste generation in the operation flow, according to the USEPA, United Environment, in 2017, value stream mapping is one of the choice to implement it. So we know that VSM is one of the tools of lean manufacturing. So we want to combine the theory of cleaner production with the one of the tool of lean manufacturing, and we pick up VSM as one of the tool. So because VSM is normally applied to improve the current state issue of the operating condition, and it can create better future state process, or we call that future state management, FSM. It is vital for company to improve the survival strategy to comply with the needs. In 2014, one of the paper that I have read, Brown said that he identified that the conventional VSM does not take into account both environment and societal metrics, which are actually is very important for evaluating the sustainability of production line. So as examined, the economy of manufacturing line, most of which are in regard to the cycle time, lead time, and change out time or changeover. So to mitigate the sustainability issue while obtaining a new knowledge for study that we want to do, by mingling the benefit of the lean manufacturing and CP or cleaning production with the most powerful lean tools, which is VSM, a simple and minimal cost to find and assess the lean environmental waste aided by occupational safety risk. So the sustainable measure through CP could be embedded if we do modify of the VSM known that we call cleaner production VSM or CP VSM, a powerful visualization tool for lean to promote the sustainability of manufacturing company. Therefore, it is important to study how lean tools, particularly the VSM, can be extended to take account not only limited to the economic point of view, but capable to harmonize with the environment consideration and social aspect as well. So we know that we have the issue of cleaner production. We know how cleaner production can minimize waste. But we know also lean manufacturing is very good tools for eliminating waste in production line. So how we want to combine, based on the information that I already told you before, we take one of the powerful tools of lean manufacturing, which value stream mapping, and then from there we modify this tool and make an extended value stream mapping that we call CPVSM, whereby this CPVSM will not only take account in terms of economic point of view, like cost and so on, but it also will take care of the issue of environment and also social, right? So I hope until now you understand that what is my idea. Don't worry, I will give two case study, the real case study that we have done and solved by using this EVSM or extended VSM, or we call that CPVSM or CPVSM. So LM and CP, lean manufacturing and cleaner production, have the same objective to reduce waste, that we know that. So both lean practitioners and environmentalists want to see the environmental waste in process and reduce hazard to work. So in Malaysia, the problem, like I told you before, Malaysia SME with small scale below than 20 permanent worker are the difficult to achieve the requirement, because they usually majority of them, because the number of workers is small, so they need to do multitasking job. So I think this is one of the way that can help them, right, to strategize, to implement Kaizen team, and to solve the problem of CP by using extended VSM. So this is VSM. Maybe some of you know what is VSM. VSM, like I told you before, this is value stream mapping. So whereby in VSM, all the information in material and process information mapping is there, right? So I have been practice this VSM throughout my life. When I've been working before, I've been working in Japanese company, in European company, and on top of that, when I'm studying in Coventry before, I have opportunity to go to Jaguar factory, whereby in Jaguar factory in Coventry, they implement the value stream mapping, right? Jikalau kita kata dalam bahasa Melayunya, value stream mapping ni, they show that we need to map everything. What is our problem? So based on that, we can do improvement. We cannot lie. We cannot lie problem that we have. We need to put everything. You know, I have one story also. I really do some consultation work, or sometimes majority of my research is in industry. So one company have called me, said that, Effendi, can you help us to develop the value stream mapping? So I say that, okay, we can help you, and then, but with the help of my student. So at the time, to do the value stream mapping, you can see here, when we want to develop the value stream mapping, when we want to develop the value stream mapping, here we need to do this is the production line, right? So the flow and the mapping of the production line. So we need to know each of this workstation, the real capacity and so on. So we need to have a real data. So, and then when I send my student there, so they start to do the time study and so on. So when they start to do the time study, and then they, first of all, they get all the data from all the engineer there. So when they get all the data from engineer there, when they come back to me, and then they calculate the VSM, it showed that they have no problem at all. Because value stream mapping actually is very dynamic tools. So when they give to me, they say that, sir, actually this company don't have any problem because they achieve the demand. I say that it cannot like that, because their department, the CEO of the company said that they have problem in their production line because they cannot achieve the demand and so on. So I take all the data, I check the calculation, and the calculation is correct, and I bring all the data and also the mapping, and then I send that map to their CEO of the company. And then the CEO said that, how come if the calculation is correct, but we cannot achieve? I said that value stream mapping will not lie. And then in the end, after investigate, we know that all the engineer there cheat the data. They try to manipulate the data to show that their production line is okay. This come the problem. This come when the issue came and said that, okay, in that case, I can't help you, because to develop the value stream mapping is not easy job. It takes months actually to create the data, to get the data. So we need to get a real data. If we see, okay, this is our problems, and from there we can try to solve that problem. If you don't give the real data, you cannot solve the problem. So this is VSM. So I told the CEO like that, and then the CEO called all the engineers, said that we cannot like this. The reason I asked you to help our team, my team, to get a real data, because we want to solve the problems, not we want to create the problems. So after discuss, and then it takes us 1 month to calculate back all the data, and Alhamdulillah, we get the data, the real data. And then from there, we do some improvement, and then we can show it that value stream mapping can help the production line, to improve the production line, to eliminate the waste. But that time only in terms of economy part, like cost, waste, and so on. But now we're talking about how the value stream mapping we can use to help together with the cleaner production by using extended value stream mapping, or we call that CP VSM. So I think the next slide. Also, this is the objective lah. At the time when we went there, so this is our objective. We want to propose propose and design the new way to determine the sustainable waste by using CPVSM, because before this they don't have any word of CPVSM. This is what we introduced, and then to analyze the benefit of CPVSM in promoting CP through simple and low-cost lean tools to promote the sustainable lean manufacturing implementation. So this is method that we have done, right? We make a research gap, because when we want to develop the VSM, a new VSM, we need to know the current issue based on the literature review. So we know that never people have created before. So, and then we try to design and develop the CP VSM, and then we evaluate and validate that, and then we try to propose the new. And then this research is not it start from 2016, and we continue that to improve till now. So the research is still continue till now. So this is basic understanding. I assure one of the some of you is all the students. That's why I just put a simple methodology like this, to know that this is method that we have using. For example, we have tried to use observation, semi-structured interview, focus group discussion. We also do the time study, and for propose the CSM, the current state map, we use Ishikawa diagram, YY analysis, Yamazumi chart, spaghetti diagram, and so on. So I just want to show, because I know that some of the audience here is a student, so at least you can get a clear picture, right? Again, I repeat, we're talking about the cleaner production and how we want to combine cleaner production with the lean manufacturing, and we pick VSM as one of the lean tools, and we make the CP VSM as the extended value stream mapping to combine the CP and to get to settle the issue of economy, environment, and also for sociometric assessment. And then this is the research flow, right? I think this is all the parameters that we take. For example, for social metric assessment, we use noise level and working environment risk level survey. For noise study, this is example of tools that we have used. For working environment risk rating, this is step that we have done until develop the EH stem. All right. So this is the how we how that CP and M have become important synergy. So this one we construct how we construct the CP VSM. So we know that. Okay, so this is the issue of information of economic value, and then this is talking about the social value, right? And also this we're talking about the environmental issue. So CP VSM is recommended encouraging energy efficiency with a visual control such as energy dashboard to visualize if the energy goals are met. This is the more important thing. As can be observed, framework to extend CPVSM is to assess the sustainability performance comprehensive to be considered a sustainable tool due to counting of environmental metric and also the social metric. All right. So the comprehensive CPVSM for sustainability must not only serve as a tool to help identify area of potential economy, but also for environment and social waste impact. Okay. All right. So now I showed you example of case study. This is a real case study. So this is company, we call it ABC Recycling Sdn Bhd. You stay in Seremban. It's an SME company. So what is the product? It's copper chips, fiber powder, previous metal, plastic, and so on. Number of operator is around 15, and we here from 2009. Right, so this is the location in Malaysia lah. So this is the CPCSM, right? Okay, this is the VSM. Then actually it's not easy to get all this data. So this data, the valuation mapping that have been drawn before. So this is the information that we can get. We get the water consumption, electrical consumption, fuel consumption, wastewater generation, solid waste generation, and so on. This is carbon footprint that have, and then we put this indicator, the EHPSO, which one is EHP, and then I will explain it later. So in here, right, this is all the information that we get. You see, you can find this is the production line, workstation 1, 2, 3, 4, and 5, and this is all the information. This is come from when we get order. This is the warehouse where they receive the order. This is an indicator of the supplier. We know that 2-month forecast and weekly order they will receive, and then how shipping they have been done, and then this is the non-value-added non-value-added time and value-added time. This is the value-added time. This is non-value-added time. This is a production time. It's 1,800 minutes and so on, right? This is how we want to calculate the VSM, and then this is the extended VSM or CPVSM, whereby we include water consumption, electrical consumption, fuel consumption. Before this, we don't have any. The VSM is not included this one. When we put the CP, the cleaner production, and then we put everything, the information in here. All right. Okay, this is all the information. Okay. All right. Okay, so based on the CPVSM, what we need to do is because like I told you before, again I show you, when we have all the information here, we know that where actually the problem in the production line, and then from there we want to tackle which part have been, I think maybe the bottleneck, or in terms of problems, water consumption problem, or we're talking about the monthly carbon footprint and solid waste, which one is problem, which one is not. And based from there, we try to improve by using type analysis, Ishika diagram, YY analysis, and so on. So we have done YY analysis, and on top of that, so this is the issue that we have where I say that they have long waiting time, and then the workstation is receiving and crashing. And then for expected outcome, we want to tackle in terms of economy, environment, and social. So for economy, we're talking about the transportation, waiting, inventory, and motion. For environmental, we're talking about the reducing electrical usage, reduce fuel usage, and reduce solid waste generation. And for social, we're talking about the noise level and also high speed component. So this is the detail of information, right? We know that the outcome is this is new procedure expected to reduce 50% and so on. We will reduce electricity usage, cut down and so on. So how we want to settle it? Not only by using check sheet, but we try to take how potential Kaizen that can be implemented. Alright. What thing that we can do based on the value stream mapping, we develop the CPM, the CPVSM, and then we try to get YY analysis, and from there we try to get Kaizen activity. For example, here long waiting time, unplanned machine shutdown and downtime, unplanned machine down, they have installed inverter, for example. So this is potential option that we give to the company, right? And then we try to implement. This is many activity that we have done, right? Okay, do not track recycling process. So for example, our suggestion is implementing FIFO by placing storage of PLCB and product, all right? Okay, so many things that have been suggested to them and try to improve. And then as a summary, this is the suggestion for improvement at the ABC Cycling Sdn Bhd. For example, perform first party audit supplier and set a certain criteria, implementing TPM on all machinery and related equipment such as motor, pump and pipeline, implementing FIFO, implementing 5S and work in progress temporary storage area, impose proper PPE applications, signage and security training. So we can see from the good thing of the value stream mapping, I told you before, when we map all the value stream mapping, we can see everything. And then when we combine with the CP information, and then we try to implement Kaizen based on the CP VSM, and this idea came, right? You can see how powerful the tools of VSM. So this is the CP. This is the CPFSM. Before this is the CPCSM. Is a current step map. This is the future step map. Whereby based on the Kaizen, we try to do improvement, and this is the result. To show that, for example, for workstation 1, we try to improve by using 5S, PPE, TPM, and FIFO. For workstation 2, we plan to implement the same thing, and so on. And then from warehouse, we try to implement the 5S and FIFO. And what is the result? That is the thing that we want to know, right? Because company, when you do collaboration, they just want to know the result. We as the academician, more on the theory part to prove our theory and so on. But usually company, they are straight away, they want what method, they don't care. They want to know, what they want to know is whatever tools that things that we want to implement, they will get benefit also. So we show that after implementing VSM, I see this. So this is that they get, right? You can see the improvement in terms of economy. The non-value added before this is 10 day based on CPCSM, because CSM is the mapping, right? When you start to map, they say that non-value added is 10 days. And after we do the improvement, mapping, try to do Kaizen, it improved to 5 days. And also the crushing workstation, before this, the value added is 92 minutes, and the carbon footprint is 9,000, more than 9,000. And after that, I've been improved. You can see this is all the information in each of workstation, right? Each of workstation, right? So Alhamdulillah, we managed to show and to convince them. Like I told you before this, if it's real CSM, we're just talking about the economy part. But now we're also talking about the environmental part also, whereby the carbon footprint already reduced. Right, this is more important thing, right? And what on top of that, before this, the company don't have any calculation. So when we came, we calculate to them, we show them, you need to measure by using this calculation based on the standard calculation, right? Yeah, we can see how reduction have been done by using the CPVSM. Okay, in average, so they can reduce 5 days for non-value added, 5,582 minutes of value added, and reduce almost 2,000 carbon footprint. And if we I try to do some summary. So this indicator, we're talking about the electrical system, hazard, pressure system, and high-speed component. The calculation is based on this indicator description. So we do some survey, and then we get all this data, right? You can see the improvement of each workstation. So this is the CPVSM, the current state map. This is future state map after we do the improvement. So we tackle all the aspect, right? Okay, you can see this. So I go very fast, and this is the overall improvement. So you can see before and after, right? The electrical system also have been reduced, and so on. So for assessment, this is example of picture. So the company in charge all the ways, right? So we help them, right? Whereby we implement, like I told you before, we try to implement 5S, we try to implement FIFO system, and some of the machine don't have any preventive maintenance. That's why they always have a what? Always have a ideal time, or the OE quite high, quite low. So that's why we try to improve that by implement TPM, total productive preventive maintenance, right? So this is all the example. And on top of that, to make sure to verify, not only verify, to validate our theory at the time, we try to implement to another company, right? This company also is a plating company. They have quite a lot of issue also, but it's okay. So the CPM, this is the CPCSM. So I just cut. This is the velocity map that we have done, right? And then this is to cut the story. This is the suggestion for improvement that whereby we try to implement Pokayoke, and then still we implement TPM and impose a proper PP application, signage, and schedule training. You can see that we enhance the process control by adding measurement device such as install the flow rate meter, level sensor to optimal solution control. So everything here, that information that we get when we do the CPCSM, we try to give a suggestion to the company and try to implement. And after that, based on our suggestion, so this is the CPFSM, whereby improvement that have been done, right? This is improvement that have been done, and this is the benefit that the company get from the process of from the CPCSM go to CPFSM. So the cleaner production, current state map, and cleaner production, future state map. So we can see that, so this is improvement. All right. I just go very fast. Okay, so in average, we managed to reduce 5.1 days of non-value added and 802 seconds for value added, and reduce the carbon footprint for 4,230.91. So based on this summary, this is the process of the company. So this is the CPCSM, this is the activity of CPFSM based on electrical system, hazard, this is the indicator, right? This is the description of potential operator risk, right? We give all the information here, you can see, right? right? There's an improve of all the, right? Okay, so this is the social metric improvement of death plating, the another company, right? This is the company. This is the company that we have went to and tried to improve, right? Okay. All right. So this is the comparison that I told you before, whereby we can improve from in overall a comparison between CSM and FSM at ABC Secretariat and comparison between CSM and FSM at DF Platinum and Berhad, whereby the here is 10 days and go to 5 days and so on, right? So in conclusion, the CPVSM as an useful tool to identify the sustainable waste, whereby it's economy, environment, and also safety and so on. And also better visualization for each sustainable waste at every workstation, exact hotspot and correct point of sources. Before this, when we don't have the VSM, we don't have the, when we don't do the VSM, we don't have the current statement. So when we don't have the current statement, we cannot visualize. But now we already can, when we met, we can visualize and we can add on the issue, the information of CP to make the extended VSM more synergy and so on. And for synergize with a low-hanging fruit for Kaizen activity by minimum monetary and resources, and also as a simple, reliable, easy to refer map for continuous improvement by the safety team in the plant, right? Okay, so I think I hope you'll be understand and to get a clear picture that what I want to show you. Maybe it's just a simple case study, but even though like that is one step ahead what the method, because this method we create by our own self based on the literature review and try to implement a new method. And currently we try to improve more the EVSM with adding more parameter and so on. So in this because we believe in this method, it will help this kind of company, the recycling company, because if not, they just throw the waste outside of the company, and then it's not good for our environment. So I think that is all for me. How many minutes? I think I also don't think. Is it enough?
Enough, Prof. Enough, Prof.
Alhamdulillah.
Thank you very much, Associate Professor Dr. Effendi Muhammad, for giving the great presentations. And then last but not the least, we go to the last speaker, Associate Professor Dr. Siti Mahsanah Budijati. She is a lecturer of Industrial Engineering Department at Ahmad Dahlan University, Indonesia. She has received his bachelor degree in Agricultural Industrial Engineering at Gajah Mada University, Indonesia, and taken her master degree at Bandung Institute Technology, Indonesia in Industrial Engineering. And then her research interest is supply chain management. Now, allow me to welcome the speaker, her respectable Associate Professor Dr. Siti Mahsanah Budijati, to deliver her presentation. Please join me in welcoming Associate Professor Dr. Siti Mahsanah Budijati with a round of applause.
Okay, thank you, Bu Hayati, for the time given to me. I will share my screen.
Okay, please.
Can you see my screen?
Yes.
Yep.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Okay, on the I will present.
Waalaikumsalam warahmatullahi wabarakatuh.
Entitled Reverse Logistics and Handling the Use Cell Phone. Okay, I'm Siti Mahsanah Budijati. I'm from Industrial Engineering Department, Universitas Ahmad, Dahlan. There are 8 outlines that I will present. The first is about green supply chain management and reverse logistics, and then types of reverse logistic flow, about e-waste. Fourth outline is about used cell phone. And then the fifth is actors in the used cell phone reverse logistic, and then drivers of reverse logistic activities. The seventh outline is the handling of used cell phone, and the last is current and future research in the used cell phone handling. Okay, before discussing further this material, it is better if we first understand the background of the environmental concept emergence in the companies. First, currently, the company's intention to environmental sustainability is increasing. There are several factors encourage company to pay more attention issues. This is because the reduced availability of raw, the existence of regulation on environment, and the consumer pressure for the companies to produce product that is more environmental friendly, and the management commitment to environmental problem. Okay, this understanding of corporate responsibility for environmental consistently increased since 1992 summit in Rio de Janeiro, Brazil. And green supply chain management is a form of company commitment in business that is in line with the concept of environmental sustainability. Okay. So here first, we will discuss what the green supply chain management is. There are 2 definitions that I present here, although there are many other definitions from some authors. The first definition is from Wilkerson, which is that green supply chain management is a method that integrates environmental aspect into green supply chain management. Green supply chain management includes the role of the environment in the creation of supply chain value, improving supply chain operation by involving solution from environmental aspect. And the second definition is given by Sri Vastava. This is the green supply chain management is integrating environmental thinking into the supply chain management, including manufacturing design, material sourcing and selection, manufacturing processes, delivery the final product to the customer, and as well as the end of life management of product after its useful life. So it can be understood that green supply chain management is incorporating environmental element into supply chain management. Next, we talk about reverse logistics. There is some definition that I read here from Rogers and Timben Lemke, and from European
Miss Masana, I think you mute your phone, so you have to unmute it first. Yeah, you're in the mute condition, so yeah, thank you.
Okay. Okay, I continue my presentation. We talk about reverse logistics here. Yeah. There are some definitions that I write here from Rogers and Timberlemke and from European Working Group on Reverse Logistics, and then from Reverse Logistics Association and from Jingbo. Okay, from this definition, it can be concluded that reverse logistics is the activity of managing end of life and end of use product from the point of consumption to the point of origin, which is in line with green supply chain thinking. We can see in this picture the relationship between green supply chain management and reverse logistics. This is a green supply chain management scheme. You can see here that the green supply chain management is included importance of green supply chain, green design, and green operation. And the reverse logistics, it can be seen here, it's the part of green operation. Okay, next, we will look at the differences between reverse logistics and forward logistics. Here are shown some of the reverse logistics characteristics that differentiated from forward logistics. First is the first characteristic of reverse logistics is uncertainty in supply. It means that the uncertainty is in the term of time, quantity, and quality of product written. And the second characteristic of reverse logistics that differentiates from forward logistics is there is a unique inspection. There is a unique inspection because the product written in reverse logistics is the quality is varies widely. And the third characteristic is the flow. Converges from the source of end of life or end of use product to the reuse market. And the fourth characteristic is inbound flow. That the flow in reverse logistics is low volume but frequent. So this is the four characteristics of reverse logistics that differentiate from forward logistics. Meanwhile, there are two types of reverse logistic flow. The first is closed loop reverse logistics, or also known as closed loop supply chain. Closed loop supply chain occurs if the reverse logistic flow is reunited with the original forward logistic, which means that the OEM or original equipment manufacturer carried out the reverse logistic activity to take back end of life or end of use product from consumers. This figure illustrates the closed loop supply chain, whereas the reverse logistic flow meet to the forward logistic. On the other hand, the open loop reverse logistic flow, are also known as open loop supply chain. It's occur if the reverse logistic flow does not directly meet the original forward logistic. It's mean because the reverse logistic activity are carried out by parties outside of the OEM who take part in the collection and handling of end of life or end of use product. The second picture here illustrates the open loop supply chain, where the reverse flow does not meet to the forward logistic. Okay, now we talk about e-waste. E-waste, or electronic waste, is also known as WEEE, as an abbreviation of waste, electrical, and electronic equipment. There are three definitions presented here, namely according to the EU WEEE directive, and the definition from Basel Action Network, and the last definition is from Economic Cooperation and Development. From this definition, in short, e-waste is waste that comes from electronic and electrical devices. And there are two types of e-waste that are white goods and brown goods. White goods is such as refrigerators, washing machine, and microwaves, and the brown goods such as radios, computers, and cell phone. And all of these e-waste can be handled by reverse logistic activities. Now, we will discuss specifically about used cell phone. The used cell phone contains several material which is harmful for the environment and the human health if not handled properly. This hazardous material is like lead, cadmium, mercury, hexavalent chromium, and flame retardant. Here is explained that cadmium from one cell phone battery can contaminate 600,000 liters of water. So you can see this is the dangers of the material that contained in the used cell phone if your cell phone is not managed properly. Here also explain the several other materials that can endanger in human health, such as mercury can poison human and damage the nervous system. And this is lead, which can interfere with the circulatory system, kidney, and so on. And chromium can be absorbed into cell, causing various toxic. And cadmium can damage the kidney because it enters the body through respiration and food. Okay, but if managed properly, this used cell phone waste provide several advantages, such as one recycled cell phone is equivalent to the energy to run a laptop for 44 hours. And the advantage of recycling mobile phones, it can be reduce the potential for greenhouse gas pollution, or equivalent of 4 million motor vehicles. If Americans recycle about 130 million each year, it would be enough energy store for the use of more than 24,000 homes. But if thrown away, a cell phone takes 14 million years to decompose it. So you can imagine it takes a very, very long time to unravel a discarded cell phone in the environment. And your cell phone is also contain precious metal such as gold, copper, and silver. And this precious material can be reused with the appropriate recycling process. Next, we discuss about at least 4 factors and the use cell phone reverse logistics. There are, first is consumer. Consumer in the reverse logistic activity or end user act as suppliers because the reverse logistic is take the end of life or end of use product from consumers. And the second actor is actor in the formal channel. It means the OEM parties who take back use cell phone. We call it actor in formal channel. The third actors is actor in the informal channel. This is the parties outside of the EOM who handle the use cell phone. And the last actor is a regulator or policymaker or government, that they are the party that set rules and policy of handling of use cell phone. So these four actors influence the activity of reverse logistic on handling use cell phone. The following is an example of several global players outside of the EOM who handle e-waste as an informal channel. There is the 5 top e-waste management startup. Yeah, we can see here they are from many countries in the world, but none of them is from Indonesia. So this is the 5 top e-waste management startup. Next, what the factors that can drive a company to carry out reverse logistic activities? There are 4 factors that are mostly mentioned in the literature. Okay, first is the driver of companies reverse logistic is because economic reason. Economic reason is wages is the term form of the availability of alternative raw material is the manifestation of economic opportunity. And the second driver is legislation as a form of environmental regulation that obligates company to carry out reverse logistics. And the third drivers is environmental reason, which is the form of the company adheres to values the environment. And the last driver is corporate citizenship or social responsibility, is the set of value or principle held by company as a social responsibility to take activities in certain ways. Okay, now how is the handling of your cell phone in Indonesia? Some of the phenomena that were observed, there are 5 phenomena that were observed, that are first, that the second-hand market as an informal channel are highly developed in Indonesia. And the second is some activities in informal channel are harmful for both actors and the environment. The informal channel is well known by consumers. So many of cell phone consumer in Indonesia, they will sell the used cell phone in the second-hand market. But on the other hand, the take-back program offered by OEM as a formal channel is not well known by consumer. So there is no specific regulation in Indonesia for handling e-waste. It has been included as B3 waste or toxic and hazardous material. With this phenomena, it is necessary that we can have research to manage that use cell phone handling so that the reverse logistic is not harmful for the environmental, but still give the benefit for the informal actors. So we did some research in this area. The following is some of our research that has been done and the future research plan. And we see here our research that have been carried out included exploratory studies on consumer, environmental actors, formal actors, and regulation. And you can see here, this is my first research about conceptual model of consumer intention to participate in use cell phone take-back program. And then the consumer post-consumption behavior. The third research is about the influence of the government and economic drivers on consumer intention to participate in the take-back program. And then the research about the influence of environmental attitude on consumer intention to participate in the take-back program. In addition, there is also research in the term of literature studies with meta-analysis and research on the reverse logistic model that combines the formal and informal channels. Okay, this is the analysis of the driving inhibiting factor for informal actors to collaborate with formal actors, the analysis of driving and inhibiting factors for formal actors to collaborate with informal actors, and the analyzing the driving and inhibiting factor for formal actors to conduct reverse logistic activity. And this is the research about the second-hand market actors' intention differences on the use cell phone handling collaboration as a basis for reverse logistic network design. And we also conduct the research and analyze the driving and inhibiting factor for the regulator to establish regulation for the use cell phone. And the following is the future research plan, which include model development for determining the location and reverse logistic network for handling use cell phone, and research about model development for determining cost, revenue, and profit sharing between formal and informal channel in the collaboration for handling use cell phone, and model development for use cell phone reverse logistic transportation that minimize cost and environmental damage. And the last future research plan is the meta-analysis to explore the relationship between companies' environmental activities and the performance of the company. As additional information, there is a local e-waste collection program. It's called the Indonesian Electrical Waste Care Foundation, initiated by Farah Iba and Rafa Jafar. It is an electronic waste collection point with drop zone in 13 cities in Indonesia, including in Yogyakarta. Maybe we can search this drop zone for your cell phone if we will participate to give our use cell phone. So we participate too in the environmental sustainability. Okay, that's all I want to explain, maybe in just a short time. Thank you for your attention. Maybe useful. Assalamualaikum warahmatullahi wabarakatuh. And I return the time to the moderator, Bu Hayati.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Associate Professor Dr. Siti Mahsana Budijati for giving great presentations. Ladies and gentlemen, now we come to the question and answer session. I have already had several questions here. Please let me share the screen. Okay. Questions to Prof. Tunyaluk Ratugdi from Leni Halim. There are several questions. The first question is related to the emerging contaminants such as NDBPS, etc. Does the BAC require certain concentration of these contaminants before the water treated in BAC? And then the second question is after BAC reach the maximum operation time, what kind of regeneration process that must be applied to restore its removal capacity? And then the last question is from Ms. Leni Halim. What kind of activated carbon that is used in BAC? Is there any special treatment for media preparations? Prof. Tunyalu Rakudi, please answer the questions. Hello? Prof, are you still there?
Or maybe we could go to the next question for Dr. Effendi first.
Okay. We go to the next questions from Leni Halim also. I have a questions related to CO2 calculations. May you share how to get the data for calculating the CO2 equations per process and what kind of data and assumption? Is it similar to calculating inventory in life cycle assessment? Thank you very much for your response. Associate Professor Dr. Effendi Muhammad, are you ready to answer the questions?
Yes, Ibu. Cuma boleh tak Ibu kita, saya nak share sekejap skrin, boleh?
Okay, boleh. Okay, please.
So dapat lihat
Dapat.
Okay, this is how we when we develop the CSM. Saya dah baca soalan tadi, saya cuba ringkaskan. So for environmental waste, the CO2 e-waste was estimated by using United Nations Environmental Program, UNIDO 1991, USEPA, Lean Environmental Toolkits, and also for the guideline for green industry audit, DOE 2014. So for CO2 quantification, basically this is the carbon monoxide equivalent information was significant data. Semua sekali saya ceritakan sikit. Okay, for water consumption, the equation like this, and then electrical consumption, the equation like this, and based on this one, in the end, because the suggested CP option together with estimated economic return, CO2 emission reduction were discussed in detail in the next section, whereby this is how we calculate the total carbon emission based on the raw water consumption information, electrical consumption, fuel consumption, wastewater generation, and solid waste generation. And this is the emission factor of environmental battery, right? And then this is the CO2 equivalent emission. So I hope it will answer the question that based on siapa yang beritahu Leni?
Yes, Professor.
Yeah, you asked me about how we calculate, right?
Yes.
So this is the detailed calculation.
Okay, thank you so much. It's very clear, Professor. Thank you.
And after this, I will try to share to the maybe the I will share the So this is one of our publication. Dapat nampak tak?
Not yet, Prof.
Not yet, Prof.
Yes.
Yes.
Okay. This
Okay.
is one of publication whereby we have 3 publication doing until now. We have 3 publication. This is 2017. We have also 2018 and 19, 18 and 19 for this issue. I will share this publication throughout this conference to webinar whereby you can read more.
Okay, thank you so
Inshallah.
much, Professor.
Okay.
Okay, thank you, Dr. Effendi, for the great answer. And then for the next questions, Professor Tunyaluk Ratuti, are you there? No, I think he has a meeting because previously he said to Mr. Miko to say about he has a meeting for this time. Okay. Okay, I think that's all for the question and answer. Ladies and gentlemen, we finally come to the end part of this webinar. Before I close the webinar, I would like to take the conclusion from what the speaker have presented, that there are many ways to protect our earth, such as biofiltration for water treatment operation, cleaner production system, and reverse logistics. To celebrate the Earth Day in this April 22nd, 2021, we must aware to the importance of protecting our planet, saving the environment, creating a better future settlement. That is the tagline of this international webinar, which can improve our awareness to create safe environment and more sustainable in the future. Okay, finally, I'd like to thank you so much to the speakers for the informative and interesting presentations, and to all the participants for the very active participations. Hopefully the webinar will be beneficial for everybody. Amin, amin ya rabbal alamin. Please give applause for the speaker and for you all. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for all the speakers, Professor Effendi, Associate Professor Siti Masana, and Professor Tom. Too bad that he has to leave the meeting earlier. He said to me that he has a meeting today. So yeah, it was a great webinar, to be honest, people. We only have one Earth, but somehow we always think that, yeah, we have another planet to live on. Like, it's all about a race to Mars, if you heard recently. And yeah, before we end the meeting today, to all the dearest guests, we have a closing statement from our head of, I don't know if it's a department or a study program. Yeah, she's already there and her camera is on. The time is yours, Miss Tami.
Okay, thank you very much, Mr. Miko. In here, I'm a head of Industrial Engineering Department. I would say to thank you for all the speakers for in international webinar, and all participants from our university, and our international participants from our collaboration partner. Okay, first I want to thank you for the speaker, Prof. Tunyaluk from Environmental Engineering Department of Content University. Thank you for Prof. Effendi from Manufacturing Engineering Department from University Technical Malaysia Melaka. And the last one is for Professor Masana from our department, Industrial Engineering Department of University Ahmad, Dahlan, Indonesia. The second, I would like to explain the aims of this international webinar. And the participant is not just from Indonesia, but our international partner collaboration. I want to share our activity. Once again, thank you to the speaker. Share about the expertise, the research, because in here, maybe we don't have same the department, but I think this is multi collaboration, multidiscipline. So our participants have add knowledge about how to create our environment. Maybe for the research from Prof. Tunyaluk, we can, as industrial engineering department, we can use the product for solve the problem about the water treatment, even in household or industrial, from industry. So we can have a point, another point of view relate to the environment. So from Dr. Effendi has to like to CSM is our method. We know about that. So I think that our participants can relate about that method to solve their problem in here, because I think that sustainable three pillar economic, social, and environment is important to know to relate in our industry. So this is my conclusion. Last one, thank you very much for all all speaker and all participants too. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you.
I think we have Prof. Tom in here again today. If it's possible, Professor, you can answer several questions first before I close the meeting.
Oh yes. Okay.
Sure.
Yeah.
Okay.
Actually, there are 7 questions, if I'm not mistaken. Like the first and the second one, you have already answered it, but you can re-answer it again in this orally. But if you want to skip several questions, like you have a meeting today, it's all yours, Professor.
Yeah, I can answer the question, but I think I already answered some question, but I'm not sure what the rest of the questions are. Could you read it to me?
Yes. Okay. Maybe Miss Hayati, could you share the screen,
Okay.
the one that you write down before?
Yes, here you are. Yes, here is the questions from Miss Leni Halim. The first question is related to emerging contaminants such as NDPPS, etc. Does the BAC require certain concentration of these contaminants before the water treated in BAC? And then the second question is, after BAC reach the maximum operation time, what kind of regeneration process that must be applied to restore its removal capacity? And then the third one is, what kind of activated carbon that is used in BAC? Is there any special treatment for media preparation? Prof. Tunyalu,
Sure.
can you really answer the questions?
Sure.
Okay, please.
The question is for the BAC. Does BAC require any certain concentration of this contaminant before the water treated in BAC? I'm not sure what this question is, but I think the the question is about maybe what the range of concentration, right, to be treated. Is that I'm not sure, but yeah, the concentration is very, but right now we're looking at the concentration of contaminant in level of microgram or nanogram level, so it's very low concentration. It's not I would say BAC has been around for 20 years, but it has been used in the water treatment. Is great, but during the past last 5 years, we are looking at these contaminant which is very low concentration, whether the BAC technology could remove it or could treat it. Okay. The second question is after BAC reached the maximum operation time, what kind of regeneration process that can be used to restore the removal capacity? What we did is that we replaced the media, okay, and the media, if it's exhausted, we can use the chemical treatment, kind of treat it first, and then we actually the process to regenerate the activated carbon is to burn it again, and under the steam to purge all the absorbed organic out. So that's how we do it. And the third one, what kind of activated carbon is used in BAC? I think it's related to the second question. The activated carbon can be made of several things, like for example, coal, wood, biomass material, or even sludge. But yeah, the method of making activated carbon is to activate it with the steam to make it porous. To make it porous, first we have to pyrolyze the carbon first to turn the biomass to the coal, and then we have to activate it using steam, or some people using the potassium chloride or other chemical to create the pore in the structure. Okay, and I can answer the other questions from the second person here. Yeah. The question asked about the water purification regarding biomechanism in the biofiltration. There are one statement said that microorganism expanding everywhere on the top of the BAC contaminant. The question is, what if microorganisms overpopulate in water in a biofilter, and the water from this cycle is for human consumption? Actually, when we have too much of biofilm, it will slough off. It will come out, okay, from the biofiltration. It will come out, and we observe that through the turbidity. We're going to have high turbidity, but if we operate properly, we can detect turbidity, and that means the filter start clogging and biofilters start biofilms start sloughing off, start coming out. So what we do is we start backwashing. Okay, we start backwashing, and the water from the filter, even it has some microorganism come out, we're gonna have another step of treatment to disinfect the water, either add chlorine or adding have UV to disinfect the water. So that answered the question that how safe it is if we consume directly without taking any treatment first. The answer is no. We should not drink the water from the biofilter directly. We should disinfect the water first, because we don't know what other microorganism it may have the pathogen. But a lot of time when we have the water filtration, the filter it is doing a really good job of removing the pathogen, because it's trapped in the filter. When we have the problem is when the filter start sloughing off, or it clogs and it cannot retain any particle. That's when we're gonna have the problem. Yeah, that's. And is there any side effect from the consumption? Yeah, I told as I answered it. You know, it's not it's not drinking alone. We have to disinfect it. Yeah, I think that's my answer to those questions.
Okay, thank you, Prof, for the answering the questions. I think it's enough, Mr. Miko.
Yeah. Okay. Thank you once again for all the speakers. Yeah. And Professor Tom, if you would like to leave the meeting first because of your meeting, it is fine. And once again, I would like to say thank you first to Prof. Tom, Professor Effendi, yeah, and Associate Professor of, should I say, Professor Siti Masana, for all your time and for all the participants and all your questions. Thank you so much. One thing for sure, we have only one Earth to live on. And yeah, environmental thingy is not just a word. We have to bear in mind that global warming, that's not a joke. It's true that we feel it every single day, every single time. It's extreme climate happen every single day, every single time. So we have to we have to keep our Earth safe until the end of time, until it's not just for us, but for our children and grandchildren. That's all. Thank you for your time. We hope you always be in a good health, even though it's a pandemic time. Stay safe, stay healthy, always wear your mask. That's it for us. We hope that we could meet you again in the future with another international webinar. Thank you. Wassalamualaikum warahmatullahi wabarakatuh. And good day to you all.
Waalaikumsalam
Waalaikumsalam warahmatullahi
wabarakatuh.
Thank you all.
Congratulations, selamat.
Thank you for the participation.
Yes, thank you. Selamat, selamat.
We'll send you the presentation and maybe papers from all the speakers if it's possible, and your e-certificate. We'll send it a few days again because we haven't made it, to be honest.
Thank you, sir.
Thank you for all the time.
Okay, sir.
Thank you, sir.
If it's possible, guys, try to turn on your cam and let's take a photo for a while. Yeah, with the remaining participant in here. Make sure you look good. Make sure you put on your makeup. Wear your best clothes. Yeah. Okay, hold on a second. To be honest, I can take the picture, so I asked my friend to take the pictures. Yeah. Okay, on the count of 3. 1, 2, 3, smile. Okay, next slide. On the count of 3. 1, 2, 3, smile. On the count of 3, in the next slide. 1, 2, 3, smile. Okay, next slide. We have 6 slides here. On the count of 3. 1, 2, 3, smile. Okay, on the count of 3. 1, 2, 3, smile. Okay, another one. On the count of 3. 1, 2, 3, smile. Yeah, last slide. On the count of 3. 1, 2, 3, Smile. That's it. Thank you, guys.
Thank you very much for.
Thank you for your time. We wish you in a good health always. Stay
Thank you,
safe, stay
sir.
clean. Yeah,
Thank
always wear
you.
your mask.